Hello, I'm Rubab, your audio navigator, and I'm here to guide you about reaction kinetics. As you all know, this is a very important part of chemistry, and that is why many questions come from here in the GATE exam. 1 to 2 mark questions could be asked from here, and again, I will stress on clearing your basic concepts about this topic. I'm starting with reaction rate and rate constants. For that, you should know first of all what is reaction rate, commonly known as speed of the reaction. Then after that, what will be the mathematical expression of reaction rate? What is the unit of reaction rate usually? Then there are few features of rate of reaction that, for example, it is always positive. It could also be explained in terms of appearance of products and the rate of disappearance of reactants. Then what are the factors that influence the reaction rate? For example, the physical state of the reactants, then the concentration, pressure, odor, temperature, solvent, electromagnetic radiation, catalyst, isotopes, surface area, stirring or diffusion limit, etc. So just go through these points in detail and see how they affect the reaction rate. Then you should know how the rate is determined for simple reactions and as well as complex reactions. Then after that, what is the reaction rate constant? Then what is the effect of this reaction rate coefficient and on what factors does it depend? For example, it depends on the temperature. What is the unit of constant? What is divided saddle theory? And next, what you need to go through is the order of the reaction. For that, you should know first of all what is the order of reaction. What is the basis on which the order of the reaction is determined? There are few methods for the determination of reaction order. Example, the method of initial rates. Then there is integral method. And another one is the method of flooding. So go through all of these and you should know how do they work. Then you should know the examples of each type of the order of the reactions. Let's start with the zero order reaction. So you should know what is the zero order reaction. How is the rate of the reaction determined for the zero order reaction? Different examples of this type of order. What are the main features of this kind of order of reaction? For example, the reaction rate does not depend on the reactant concentration, and there is a linear change in concentration with time of the reactants. Likewise, what is the first order reaction? How is the rate and rate constants determined for this kind of reactions? How are the graphs for the first order reaction like? Then also go through a few examples of this. And you should know that if a plot of reactant concentration versus time is not linear, but a plot of the natural logarithm of reactant concentration versus time is linear, then the reaction is first order. Also go through with the numerical problems related to this. And after that, what is a second order reaction? How the rate of the reaction and constants are determined. Examples of this kind of reaction. Then the graphical representation. And you should know if a plot of reactant concentration versus time is not linear, but a plot of one upon reaction concentration versus time is linear, then the reaction is second order. So for all these kind of reaction, you should know what is the definition, what are the factors determining the reactions, and what are the equations for all these three kinds of reactions. And also solve a lot of problems, conceptual problems as well as numerical problems based on these. It's going to be definitely asked in the exam. After this, you need to know about molecularity. What is it actually? And depending upon it, the reaction could be divided into unimolecular, bimolecular, or trimolecular. Start with the unimolecular reactions. Which rate law does it follow? For example, it follows the first order rate law. How is the reaction rate constant determined? Then what is Lindman-Hinshelwood mechanism? Then what are bimolecular reactions? They usually correspond to the second order rate law. Go through the examples. Then after that, the trimolecular reactions, and study different examples and the order and molecularity of that particular reaction. Then what are pseudo order reactions, where the expected order and the actual order differs. Then you should know what are the main differences between molecularity and the order of the reaction. For example, molecularity, it is the total number of reacting species, molecules, atoms or ions which bring the chemical change. It is always a whole number. It is a theoretical concept. It is meaningful only for simple reactions or individual steps of a complex reaction. It is meaningless for overall complex reaction. And as for order of reaction is concerned, it is the sum of powers of molar concentration of the reacting species in the rate equation of the reaction. It may be a whole number, zero, or fractional. It is experimentally determined. It is meant for the reaction and not for its individual steps. So you should keep all these points in mind. Conceptual questions could come from this area. Out of this, you should know about the activation energy. What is activation energy? Who gave this term? What is the unit of activation energy? What is the role of activation energy in a chemical reaction? And what is the Arrhenius law related to the activation energies? What is the Arrhenius equation? What is the relationship between activation energy and the rate of the reaction given by Arrhenius equation? What are the factors which affect the activation energy? What is negative activation energy? How is the activation energy affected by catalysts? What is activation enthalpy, entropy, and Gibbs energy? What is the relationship between these? So go through these points, the graphical representation and the mathematical representation as well. Also go through several problems related to it, conceptual as well as the numerical problems. Then according to the syllabus, the next topic is zero, first and second order kinetics. This I have already told you in detail what points you need to cover. For that, you should know what is the rate law and what are the differential and integral rate laws. Then how does the experimental determination of rate law is done. And depending upon this, how does the order of reaction is determined, whether it is a zero order, first order, or the second order. And what is the reaction kinetics which they follow. How the reaction rates are determined and how the rate constants are determined, what are the mathematical expressions for that, and what are the graphical representation for all these kind of reactions, and what are the numerous values and equations which are utilized when observing the chemical kinetics of these reactions, like rate law, integrated rate law, units of rate constant for all these kinds of reactions, then linear plot to determine K, then the relationship of rate constant to the slope of the straight line for all these three kinds of reactions, then what is the half-life of all these three kinds of reactions, what are the mathematical expressions for all these points you need to remember. And the next topic which you need to cover is the catalysis and elementary enzyme reactions. For that, first of all, you should know what are catalysts, what is their function, and how do they alter the rate of chemical reaction, what are their properties, what is the mechanism of their action. For example, the catalyst increase the rate of reaction by providing a different reaction mechanism to occur with a lower activation energy. So you should know about this in detail. Then what are the terms like autocatalysis, positive feedback and negative feedback? And then what are enzymes? Proteins that act as catalysts in biochemical reactions are known as enzymes. So you should know about the mechanism of action of the enzymes. What is the term affinity, turnover number, effectiveness factor, etc. Then how are the enzymatic assays done? Then what is Michaelis-Menten kinetics? Need to go in detail. What is the Michaelis-Menten equation? How is the Michaelis-Menten equation used for the time course kinetic analysis? You should also know about the linear plots of the Michaelis-Menten equation. Then what are the practical significance of kinetic constants? How is Michaelis-Menten kinetics defined for the reactions with intermediates? Then what are the kinetics and the mechanisms suggested for the multi-substrate reactions, like ternary complex mechanisms and ping-pong mechanisms? What is non-Michaelis-Menten kinetics, for example in allosteric regulation? And what is pre-steady state kinetics? Then after that, how do the enzyme inhibition and activation takes place? First of all, how do the reversible inhibitors work? And what is the kinetics of this kind of inhibition? How are the kinetic constants affected? Same points you need to study for the irreversible inhibition. What is product inhibition? Then what is the mechanism of activation? Then what are the factors which affect the enzymatic reactions, like pH, temperature, etc.? So go briefly through the points which I have just told you. This was all about the reaction kinetics, and I hope you found these information helpful. Time taken for its preparation is around 2 to 3 days. For this, you need to be very clear about the rate, constants, order of the reaction, and the respective kinetics. Both concept-based and numerical-based questions could be asked from here. So that was all. I wish you good luck. Thank you.